Hello, science fans! Welcome back to another exciting exploration of our planet. Today, let's talk about something you can't see, something that's all around us, yet often goes unnoticed. It's something that protects you every day. The ozone layer. This vital layer is a key component of our atmosphere. Imagine Earth spinning through space, a beautiful blue marble swirling in the vastness of the cosmos. Now picture it wrapped in a thin, invisible shield high above us, a delicate veil safeguarding all life below. This shield, the ozone layer, acts like our planet's sunscreen, providing essential protection from the sun's harsh rays. Think of it as nature's own SPF. It works tirelessly, blocking the sun's most harmful rays, specifically ultraviolet radiation, which can be incredibly damaging. Without it, life as we know it couldn't exist. The ozone layer is fundamental to the health of our ecosystems and the survival of countless species. The ozone layer lives in the stratosphere, a layer of the atmosphere. This is about 9 to 22 miles above the ground, a region far above where we live, but crucially important to our well-being. It's not a solid wall, but a region where ozone gas is more concentrated, a dynamic and ever-changing area of our atmosphere. Think of it as forming a thin, protective blanket, a delicate shield safeguarding us from the sun's potentially harmful energy. Now, here's a mind-blowing fact. If you gathered all the ozone at the surface, compressing it down, it'd be just 3 millimeters thick, about the width of a few stacked coins. Yet it makes all the difference. This seemingly insignificant layer is a powerhouse of protection. This tiny amount of gas is a true planetary superhero, working tirelessly to keep us safe from harmful radiation. It's constantly created and destroyed in a natural cycle, a delicate balance that keeps our planet habitable. Understanding the ozone layer helps us see how everything on Earth is connected, highlighting the importance of protecting our environment. Ready to dive into the science behind our invisible shield? Let's explore the fascinating world of ozone and its crucial role in sustaining life on Earth. So what exactly is ozone? It's a term we hear often, especially when discussing environmental issues. Let's break it down and explore this molecule that plays such a crucial role in our atmosphere. At its core, it's a special form of oxygen. Regular oxygen is O2, but ozone has 3 oxygen atoms, O3. That extra oxygen atom makes all the difference. This reactivity is precisely what gives ozone its protective power high in the atmosphere. It allows it to absorb harmful ultraviolet, UV radiation from the sun. Down at ground level, however, ozone can be harmful to our lungs. Ozone forms when energy, like a lightning bolt or the sun's intense ultraviolet rays, splits O2 molecules. These single oxygen atoms quickly bond with existing O2 molecules to create O3 or ozone. In the stratosphere, the constant bombardment of sunlight drives this process on a massive scale, and that's what makes it our planet's invisible shield. Now, how does ozone get up into the stratosphere? The answer: the sun. Its ultraviolet rays provide the energy needed to create ozone. When UVC rays hit O2 molecules in the stratosphere, they split them into single oxygen atoms. These atoms quickly bond with O2 to form ozone. This process, called photodissociation, happens constantly wherever sunlight hits the upper atmosphere. But the sun also destroys ozone. UVB rays can break O3 back into O2 and a single atom. This ongoing creation and destruction is called the ozone-oxygen cycle. For millions of years, this cycle has kept our ozone layer stable. It's a beautiful, self-regulating system powered by sunlight. Our planet's sunscreen is always at work. So, how does the ozone layer protect us? It acts like sunglasses for Earth, blocking the sun's most dangerous ultraviolet rays. The sun's UV comes in 3 types: UVA, UVB, and UVC. UVC is the most dangerous, but it's completely absorbed by oxygen and ozone high in the atmosphere. UVA passes through, but UVB is the real troublemaker. It causes sunburn and skin cancer. The ozone layer absorbs about 95% of UVB, turning it into harmless heat. When ozone absorbs UVB, it breaks apart, but the cycle quickly rebuilds it. Without this shield, life on land would be nearly impossible. The ozone layer's ability to absorb UVB is essential for life's survival and evolution. It's our planet's ultimate UV blocker. Imagine a world without a healthy ozone layer. More UVB would reach us, causing skyrocketing rates of sunburn and skin cancer. Our eyes would suffer too, with more cataracts and other vision problems. Our immune systems would weaken, making us more vulnerable to disease. Animals would be at risk as well. Skin and eye cancers would rise across species. In the oceans, tiny organisms like phytoplankton would die or stop reproducing, collapsing the food web. Plants would struggle, as too much UVB stunts growth and reduces crop yields. Forests and natural ecosystems would be damaged, threatening biodiversity. The ozone layer protects every corner of the biosphere. Without it, life on Earth would be dramatically different and far more dangerous. That's why this invisible shield matters so much. It's our first line of defense. How do we know all this? Science. For decades, scientists have measured ozone with ground stations, weather balloons, and satellites. Tools like the Dobson spectrophotometer and NASA's satellites give us global ozone maps. The data is clear. Where ozone is thin, more UVB reaches the ground. In places like Antarctica's ozone hole, UVB levels can double. Experiments confirm the biological damage predicted by these measurements. Decades of data revealed a disturbing trend. The ozone layer was thinning. This discovery was a planetary wake-up call. Science didn't just identify the problem, it gave us the warning we needed, and it showed us how to act. For millions of years, the ozone layer protected life on Earth, maintaining a stable environment by absorbing harmful ultraviolet radiation. That balance remained undisturbed until the industrial age, when humans introduced new chemicals into the atmosphere. Chlorofluorocarbons, or CFCs, were used in fridges, air conditioners, and aerosol spray cans. Due to their stable nature, CFCs drifted up to the stratosphere. Once in the stratosphere, the CFC molecules were exposed to intense ultraviolet UV light from the sun, which possesses enough energy to break them apart. This released chlorine atoms, initiating a destructive chain reaction. These chlorine atoms acted as catalysts, triggering a chain reaction that destroyed ozone molecules. One chlorine atom can destroy up to 100,000 ozone molecules. Over decades, tons of CFCs accumulated in the stratosphere, exacerbating the ozone depletion problem. The cumulative effect led to significant thinning of the ozone layer, creating the ozone hole. This thinning represented a significant weakening of our planet's protective shield against harmful UV radiation. The ozone crisis highlights how science can provide us with the tools to fix the problems we create. In 1985, scientists discovered a massive ozone hole over Antarctica. The world took notice and took action. In 1987, nations signed the Montreal Protocol, agreeing to phase out CFCs and other ozone-depleting chemicals. It's the most successful environmental treaty ever. Every country signed on. The protocol set clear deadlines and adapted as new science emerged. Thanks to this global teamwork, levels of ozone-destroying chemicals peaked in the 1990s and are now declining. The ozone layer is stabilizing and starting to recover. Scientists predict the Antarctic ozone hole will shrink and the layer will return to 1980 levels by mid-century. The Montreal Protocol proves that when we listen to science and work together, we can solve global problems. It's a story of hope and a blueprint for future challenges. Our invisible shield is healing. That's the power of global cooperation. The Montreal Protocol worked, but the job isn't done, and you can help. If you have old fridges or air conditioners, make sure they're disposed of properly so leftover CFCs don't escape. Check labels for ozone-friendly or CFC-free products. Some fire extinguishers still contain harmful chemicals. Choose safer alternatives when possible. Your choices as a consumer matter, and send a message to manufacturers. Share what you've learned about the ozone layer. Spread the word. Support science-based policies and leaders. Remember, protecting the ozone layer and fighting climate change often go hand in hand. By saving energy and using less refrigeration, you help both causes. Every small action adds up. Together we can keep our planet's shield strong.